Hello everyone, welcome to this channel. Now this channel has grown very fast and now it's more than 165 videos. So if you want to take advantage of accessing all those videos, just click the subscription button and a bell button. That's all you need to do. Thank you for doing that. All right, today we're going to use a mathematical induction. So to prove this expression, n is a positive integer divided by, so divisible by 5. So we know if something 5 is going to that number, for example, for x, for any number, we might solve for a. So that means a can be written as, now 5 vertical slot, that's called 5 is the divisor, or a is divisible. 5 is, so a can be written as 5 times by another integer. So a is integer. All right. So that's the theory we're going to use. So we're going to try first, step 1, we're going to initial n. So we know n is positive integer, so that means n is the greater or equal to 1. So therefore we first initial value should be start with n equal to 1. So I'm going to try left-hand side, the expression n replaced by 1 plus 4 minus 2 times by 1, and equal to 3 to the power of 2 plus 4, which is 3 to the power of 6 minus 2 to the power of 2. So therefore so that's 364 minus 4, which is 60. So 60 is, we can write into 5 times by 12. So therefore, so that proves 5 is the divisor of this number, or so this expression, so 3 when x equal to 1 is divisible by 5. So that means statement is true. So we proved the first step. So now second step is assumption. So we assume that when n equal to k, the statement is also true. So that means we're going to find that the 3 to the power of 2k, so we replace n with k, minus 2 to the power of 2k is divisible by 5. I can write down into something 5 times by another number, so where the a should be positive integer. So that's my statement, assumption. Assume that's true. So I'm going to make this become a 5a plus 2k. So that's the equation we're going to use. So this is equation 1. I'm going to use this one later. So I'm going to use the step 3, so we should call inductive step. So it means when n is the next value for the k, which is the next, it should be k plus 1. So therefore the expression becomes 3k plus 1 plus 4 minus 2 to the power of 2k plus 1. So we replace n with k plus 1. So expanding that bracket, 3 to the power of 2k plus 2 and plus 4 minus 2k plus 2. So now we got 3 to the power 2, so we put it as 9 times by 3, 2k plus 4. I'm going to leave it 2k plus 4 for the time being we're going to use. Next one is 2 to the power 2, so I'm going to separate into 4 times by 2 to the power of 2k to the power of 2k. So now we're going to substitute. So we substitute 1 into the equation. So replace this guy here with equation 1. So we will get 9 times by equation 1 will be 5a plus 2 to the power 2k minus 4 times by 2 to the power 2k. Then we will equal, expanding the bracket, 9 times by 5a plus 9 times by 2 to the power of 2k minus 4 to the power of 2k. So the answer will be 9 5a plus, so these two are collectible. We call like terms. So we call 5 times by 2 to the power of 2k. So now we got common factor 5. That's the one I needed. So I take 5 out. 9a plus 2 to the power of 2k. So now we're going to prove this bracket is, sorry, what should we use the highlighter? This should be an integer as well. So we say a is positive integer. 2 to the power of 2k also is positive integer. So therefore 9a plus 2 to the power of 2k also positive integer. So therefore the statement is also true because we call that's the factor 5. So therefore 5 also is divisor of 2 to the power of 2k plus 1 plus 4 minus 2 to the power of 2k plus 1. So when a k plus 1 is also true. So therefore we can say the statement is true or n belongs to positive integer. That's it. We solved that question using mathematical induction. I hope you enjoyed the video. And if you do, please give us the thumbs up. I'll see you next video. Thank you. Bye-bye.